Hi, everybody. Thanks for coming. I want to start by talking about my parents. My dad is an artist. He grew up in rural Connecticut, and my mom is a writer, and she grew up in a coal mining town in Pennsylvania. So to make it as an artist and a writer, you don't stay in a rural area or in a small coal mining town. You move to New York City to try to make it, at least you do in the Northeast. So they moved to New York, and of course, they were starving artists. They had no money, and they had to pick a very poor neighborhood to live in. So that's where they ended up, and you could see the picture of the neighborhood, and if you squint, you can see me in the back row of the other picture, and my sister cut off on the side, because my mother's not a very good photographer. And this neighborhood in the 1970s, when I was there, was one of the 3 points on the international heroin triangle, the other points being in Afghanistan and Thailand, where heroin was processed. 70% of the heroin consumed in the United States came through our little neighborhood, and a lot of it was used right there. So as you can see, it was a very rough neighborhood. So growing up in this neighborhood, went to school, had a normal life. You could see me there playing the clarinet, or at least trying to. And one of my best friends, who's in the other picture, Jerome, shortly after that picture was taken, was shot in the back of the neck and paralyzed from the waist down. He's in a wheelchair to this day. And so that event, when we were about 13, haunted me for the rest of my life, really, and I think really drove me to ask the questions that I do ask in my day job. Why did he end up getting shot and I ended up getting to go to college? Why was I so much more advantaged than my neighbors for the most part? And I get to have the honor of standing before you here today, and many of my colleagues, my friends growing up, did jail time or worse. Of course, not everyone, but there were definite patterns, and I wanted to understand those. And little did I know that I was actually tapping into a huge debate that's been going on for, 100 years or so, between nature and nurture, or between the two Watsons, as I like to say. John Watson, who's the behavioralist psychologist, who said that kids were blank slates, and if you took 12 healthy kids, he could turn them into anything you wanted: criminals, doctors, lawyers, what have you. And then on the other side, there's, of course, James Watson, along with Crick, discovered the structure of DNA. So really, was it nature or nurture that put me before you today and describes the differences? Well, to really answer that question, I'd need to do this experiment. I would take 2 embryos and put them in the same woman or in twin women, and then I would let them grow, and then when they were born, I would take them away from the mothers, and I would secretly plant them, say one in my neighborhood and one in a very wealthy suburb, say like Chapel Hill or Greenwich, Connecticut. And then for the next 35 years or so, I would follow them, I'd stalk them, and take good notes, and at the end of 35 years, I would know, well, I controlled their twins, so I controlled their genes, and I can really see the effect of social environment. Of course, I'd have to do this probably about 20 or 30 times to have a statistically significant sample size, and by then I'd be dead, and I'd probably be arrested, so this is not going to work. Luckily for me, in 2000, we sequenced the human genome. So no longer did we have to guess about the effects of genes on our behavior and our outcomes. We could actually just look at our genomes and ask those questions. So if you've heard of Moore's law in computing, says that every 18 months or so, computing power for the same price and in the same space will about double. Well, if you look at this chart, it has Moore's law graphed, but then it shows the cost for sequencing someone's genome that's dropping faster than Moore's law. So today, we could have you all genotyped on the way out of here, and I'd have a sample size, and I'd be able to study your genes and say, predict whether you're tall or short, how far you're going to go into school, how much money you're going to make, and aspects of your personality and so forth. Well, that was very exciting, but what happened along the way was that actually it didn't work. So we know that height is probably about 80 to 90% genetic, for example. That's pretty uncontroversial. But when we actually looked at everyone's genes and tried to measure their genes to predict their heights, we could only explain about 5%. So where is all the other 75 or 80% of height, of the genetics of height resting? It's called the case of the missing heritability. And it's sent geneticists off in this sort of soul-searching mission for the last decade or so. Well, I was coming from the social science angle, and I thought maybe they're wrong to begin with. Maybe height, for example, is not 80% heritable, and IQ is not 60% genetic. Maybe that's a false goalpost, and that's why we're not finding the answers in our genome. And to explain that, I have to back up a little bit. In the old days, before the human genome was sequenced, the way we would study the genetic effects of anything, height, liking sports cars, what have you, is that we would take identical twins and look at how similar they are and compare that to fraternal twins, dizygotic same-sex twins. And basically, 2 times the difference between how alike the identical twins are and how alike the fraternal twins are is the genetic component, because we know that identical twins are 100% related genetically, and fraternal twins are about 50% related genetically. So you can really extract out the effect of genes and the effect of environment. But the only problem is that there's an assumption in that, and that's that identical twins and fraternal twins also experience exactly the same similarity in their environments, in their nurture, in their upbringing. And we know that's not true. So we could solve that with an experiment. We know that identical twins basically are treated more alike. They experience the world more similarly than do fraternal twins. So you might not be able to tell them apart if you have friends who are identical twins, and therefore you probably treat them more similarly. So that's a problem. But if NYU would let me, I would go back to my stalking days, and I would raise 2 kids in completely controlled environments, and they're twins, and then I could solve this problem. Obviously, I can't do that either. So the answer is what I call a natural experiment alternative. So actually, I took a study that was based here at the University of North Carolina called the National Longitudinal Survey of Adolescent Health. And in it, they oversampled twins. So I had identical twins and fraternal twins, just like a traditional, what's called behavioral genetic study. Except for now we can sequence their genomes. And what did we discover? We discovered that 18% of the same-sex twins were wrong about whether they were identical or fraternal. Most of them actually were identical, but they thought they were fraternal. Maybe they had different moles, or one was taller than the other, or what have you. But for whatever reason, they grew up thinking, and their parents thinking, and their friends thinking, that they were not identical, and they were actually monozygotic twins. For me, that's a gold mine. These freaks of nature, these people who are wrong about their own twinhood, are the perfect natural experiment. Their mistake I profit from, because I can follow them, and I find I'm not stalking them. I'm just following them in surveys through the University of North Carolina, and then they are the ones who basically lived in an environment where they thought they were fraternal, but they actually have more genetic similarity than they thought. And what do we do? What did we find when we did that? So focus on the last 2 bars. If you look at identical twins who think they are identical, this is their body mass index, their weight for height. They're about 80% similar, right? If I look at the identical twins who grew up their whole life thinking they were fraternal twins, they're also 80% similar. There was no difference. I had come charging into this field thinking, I'm going to show the geneticists wrong. Social science is going to rule. And here I was, and I couldn't knock a single estimate of the genetic effects down. If you look at body mass index at the last bar, it's taller. If you look at height, it's exactly the same. If you look at ADHD, it's even larger genetic estimate. And if you look at your grades, no difference. I tried it for every possible outcome you could imagine, and the genetic effects were still there. So the lesson is to be a little bit more humble when you're doing science, that you're not going to prove the entire field wrong, and that we still have to look for the missing heritability. We still don't know where these genetic effects are lying in our genome, but we're going to find them. And I would say that still the debate over nature and nurture and how they intertwine is going to rage on. So thank you very much.